Hello, my name is Siobhan Richards. So the last time we stopped at user-defined types or reference types in C++. Today we want to look at typecasting. What is typecasting? Basically, we're moving from one data type to the other data type in our program. It's typically done on primitive types or those fundamental types that we looked at earlier. Okay, so what are the fundamental types in C++? Basically, we have these signed and unsigned integers as well as these floating point types. But there are two categories of typecasting. You have implicit typecasting as well as explicit typecasting. Implicit typecasting is it's automatically done by the compiler, while explicit typecasting, you're explicitly telling the compiler the type you want. Okay, and we'll see how these two are done. So let's start on this implicit typecasting. Let's start by declaring and initializing a few data types here. So we have this character. And just to note, by default, C++ is signed. Okay, so by default, if there's no signed keyword in front, the variable is a signed variable, right? So we have signed character. So let's call this my char. Let's call this my signed char. Okay. My signed char operand, and set that to a character. Let's make it a question sign. Okay. The other, we could do unsigned char. So you can say my unsigned char operand. Okay, and we'll set this one to a comma. Okay, well, let's set this to a comma there. Okay, let me extend this some more here. We also have our integer values, which is you have int. So you say my signed int operand. We can make this maybe 13,000. Okay. The other, we could have unsigned. So unsigned int my unsigned int operand. Let's make this 30,000. Okay. The other one, in the integer types, we have or short. So my signed short operand equals, let's make this 14,444. Okay. Let's do the unsigned short. My unsigned short operand. Let's make this one. Let's make this 1011. Okay. After short, we also have long. So that's my signed long operand. You can make this 1.2 million. Okay. And then the other one, long. Oh, wait, we need unsigned long. Okay. Unsigned long. My unsigned long operand. Okay, just remember the signed versus unsigned, we've covered it before in data types. It's just a split in the range, right? So one is from 0 to the max range, and one is you split the range in half, some negative number, 0 to the lowest negative number on this half, and 0 to the positive number on the other half. Okay, so now we have this unsigned long. Okay, and we could make this 11111. Not sure what that is, right? But it's couple. It's a number. Okay. Next one we could have is long. right? So long, long, you could say my signed long, long operand equals, let's make this 14, it doesn't matter, 255,666, 6144, okay? And then unsigned long, long. So unsigned long, long. So my unsigned long, long operand, okay, equals 32111223. Okay. All right. So we're just declaring here, right? And what we're gonna do is, after we declare all the main data types here, we'll try to assign variables to a resulting addition and see what type we could set it to. Okay. So we have char, unsigned char, and we have those W char and the other version of char, but this is the main one, right? So char, unsigned char, int, unsigned int, short, unsigned short, long, unsigned long, 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 unsigned long, long, right? These are the main numeric types, right? Integer types. We also have the floating types, right? So we have floats. So my float operand, we could set this to 23.22, okay? And then we also have double as our floating point. So my double operand 20, let's make this 20,000.331, okay? And then we're just going to assign a number. We also have long double. Okay, so there are 3 floating point types in C++. So long double, my long double operand. Okay, and then, okay, so that's a larger number there. Okay, I'm going to extend this out so it looks a little better. Right, just remember though, with implicit typecasting, if we should look here, over here, it's basically on order of promotion, right? So it's variable with the largest size will be promoted. Okay, so let's look at that. Okay, let's look at that. So let's first run this here. No errors here, so we declare initialize properly. The next step here is we'll create this variable. Let's say we're going to make it an int, right? So add result. And we're going to add all these values here, okay? We're going to add my signed operand, okay? Let's add that, okay? Plus, we need the unsigned as well. Let's make it like this here. We need the unsigned character val right there. We do a plus here. All right. And then we also need these other values here. So we could just copy those as well. Okay. So let's make this here. Let's just copy all of this here. How many times? Well, let's just copy. Okay. So Control C here. Okay. Let's copy this one. Okay. I'll copy this other one here. Okay. And we could keep them, let's keep them side by side as well. Okay, it makes it looks a little better. So we have this unsigned, we stopped at unsigned short. So we have this my unsigned short here. I mean, we could copy this one and yeah, just copy everything here. So we have this unsigned short here, and we're basically adding, right? We're just gonna add. We have this long, copy that one. Okay. We have this unsigned long as well. It's probably a faster way to do this, but yeah, I'm just gonna copy and paste here. And then last one, well, not the last one. We have long. Last one for numeric, for integer type. Right? The other one are floating points. Okay. And then we have the floating points here. So we have this float operand here. Let's first, okay, let's just add them in there. Okay. Float operand, double operand. So you can see this is a very large addition here. And then this long double operand here. Okay. All right. So let's just do this here. Control here. Let me control here. Right there. Okay. Space plus. Okay. Well, not this one. Okay. All right. So we have these types here. Okay, being added, and we are trying to say, okay, with all these operands, I want to make it a integer. Can I do that? Okay. Let's run. See if there's any error. No errors. So I can, using all of these, it'll typecast it to an integer, right? Automatically, even though double are higher range, right? So, but typically, even though we use the int, so there's no guardrails here. Even though we use the int, it should have been double, right? Because it's more precision, okay? But C++ does not complain for in this case, okay? So let's see if it loses the decimal places, right? The precision here. So standard cout add result. Okay. \n. Let's see if it lost some precision here, right? So it lost the decimal points, right? So in this case, it'll do the addition for you and remove the decimal, the precision that you have from the floating point type. So that's nice, right? That's nice of C++ there. The next thing is, notice that these character types are converted now into integer types. Okay, so these symbols are now turned into integers. So how do we typecast from this character here to a integer? Well, we would have to use explicit typecasting, right? And just to show you here, you could do a static cast call, right? What you want to move to, and then the result you want it to be. Okay. So for example, I want to make these values here into integer. I'd have to, you could say int char to int, okay, equal, that's a variable name, char to int, static cast. So you do a static underscore cast. Okay, that's like a call there, template. So static cast, what do you want to move to? You want to move to int. And then what is the expression? You could have a variable name or expression here. So let's make this the expression, my signed char operand. So my signed char operand. Okay. Let's run to see if static cast works. That's what's going on here. Expected. Okay, so we need the open and close expression brackets there. Okay, so you have to keep the expression inside the brackets. Okay, or it'll complain. So it's looking for this token. Okay. All right, let's copy here, Control C, and then comment out. so we don't print the result, and look at this explicit typecasting here. And instead of add result, we'll do char to int. Okay, so char to int. Okay, and then if we print, we'll see the integer value of this question, which is 63. And if you should look up ASCII value for this, you'll see 63. So this is static cast, right? You have others. You have dynamic cast, const cast, reinterpret cast. And you could look into the C++ documentation to see the difference, right? So let's try dynamic cast here, see if it works. Never tried it, but let's do that. Okay, some error here. Cannot dynamic cast, right, of type char to int. Target is not a pointer or reference. So dynamic cast, based on this error here, only works if the target is a pointer or a reference. So if you have to have a pointer type of variable, okay, or reference variable to dynamically cast it to the value you want. Okay. We also have reinterpret cast and static cast, but typically for these primitive types, you could just do static cast. Okay. What if I need to cast also? Let's comment. Let's copy here. Let's just take this block of code here and then comment out, and let's move to these floating point types, and this give rise to rounding. What if we want to change these floating point types into integer values? We want to round them to integer values, or round up. What if I have this float and I want to round up? But let's look at rounding down first. So if I want to round down, I would do static cast to int, right, from one of these floating points, and then I could copy the myFloat operand here, put it inside the expression statement, and instead of char to int, this will be a float to int. Okay, and then now we could print float to int. Okay, because there may be cases where we need to round to the nearest whole number. Okay, and it will round this 23 here to a 23.22 to 23. And if we do a type id.name, we'll see that it's a integer type. Okay. What if we want to round up, right? So instead of int, we want to move from a float to a double, and then make this here a double. Okay. Okay. So now we have this float here, right? We have the float. Well, it should be float to double here. Okay, let's update this. Let's go here, make this a double. So now it looks like it's a float, right? But it's not. It's really a double. If we should do type ID and do a, let's do type ID here. And do a dot name, and if we go up to the top and include that type info package, right? So include type info. All right, we'll see here it's now a double, right? It's not a float. And if you want to really, like, let's say we want to see the type of the type ID of the float. If we do type ID myFloat operand, capital F here, dot name, you'll see that's F. Right, so you see a D for the first one, which is the conversion one, and the F for the float. Okay. What if we want a long double? Can we do that? probably, if we do long double here. Okay, so now it'll still be a D for double. Well, we need to put long double here as well. Okay. Now it's an E for long double, right? So we cast from long double, from float to long double, okay? And that's explicit typecasting in C++, okay? So, you know, it's not so constrained, right? C++ will allow you to make error. So you definitely want to know, especially the implicit typecasting, it'll allow for you to lose your decimal places automatically. It's no guardrails there, okay? But explicit typecasting, you use the static cast kind of template method to change from one type to the other type in C++. Okay, so the next step, we'll look at operators, which we pair with these data types to create operations, which then creates our algorithms, right? And then we'll move to controlling these operations with control structures. All right. Thank you for listening. See you soon.